everybody. Good morning. I mean afternoon. So today is December 9. So we are on the last chapter for our spherical and plane trigonometry subject. So I already gave you a copy of this presentation, and there is a correction. So I will be showing you the correction that the presentation that I gave you last time. And the content of this presentation is the same with the YouTube link that I gave you, the two YouTube links. So those are the topics that is being discussed in the geodesy subjects for the higher students for the second year students. But those are basic concepts of spherical trigonometry and its application to the terrestrial sphere, so computation. So I just show you that because the content is just similar. Okay, so since this is our last lecture, so there will be a announcement for the exam, for the schedule of the exam, so to be posted in your Google Classroom. So anyway, so let's start with this topic. So this is the lecture 8 again. So we are on lecture 8. So this is the last topic that we are going to tackle for this course. So it's plane and spherical trigonometry. So as you all know that this is very important since this topic is very important for the field of geodetic engineering. Okay. So I don't know if you are familiar, if you have ever encountered spherical trigo in your senior high school or in the high school. But now let's start with the basic and then some of the application. Okay. So if you can see, this is the figure of the Earth. So this is called the terrestrial sphere. So because we have also the celestial sphere, so it encompasses the heavenly bodies, the stars, the center, which is the sun, the other planets, and we have the latitude, celestial longitude, and the celestial latitude. But let's just focus on the terrestrial sphere, so sa Earth muna. So as you can see, you already know that the Earth is compasses of the different elements. We have the equator, so we have the equator in the prime meridian. So the equator, on the left illustration, so we have here, so this is the equator, which divides the sphere into a northern and a southern hemisphere. So in this portion here, so this is the equator, which means yung Earth is divided into half, and then yung upper is the northern hemisphere, and the lower is the southern hemisphere. So the other great circle also, we have the prime meridian. Yung ating prime meridian naman is yung reference ng ating longitude. Kung yung equator is reference ng latitude, so for example, yung latitude is sa equator, since nasa horizontal lang siya, so this is 0. So papataas ka, mag-i-increase yung latitude mo from 0, magiging 15, 30, 45, 60, and then 90 degrees on the North Pole. So the same is true with from here. So balik tayo sa 0, then negative 15, 30, negative 45, 60, and then 90 degrees to the South Pole. So the latitude here is negative values. So another, we have the prime meridian. So prime meridian is just similar kay equator, but yung kanyang position is pa vertical. So yung ang equator is pa horizontal, si meridian naman ay great circle na pa vertical. So yung ating prime meridian, so yung most of it is known also the Greenwich meridian, where yung ating longitude is equivalent to 0. So in this illustration here, meron tayo. In this illustration, we have here, we assume that the center of the Earth is here. And then at 0 latitude, for example, this is 0, then pataas, naging 10, 20. So these are latitude here. So pataas. So these are latitude. So whatever is the angle that we can form here, for example, we draw an angle. So this is the reading of the angle. So 10 degrees, 20 degrees. So these are latitudes. So in reference to, pag nagme-measure tayo ng latitude, nagre-reference tayo kay equator. Take note, pag nagme-measure tayo ng latitude, yung ating reference ay yung si equator. However, if we measure the longitude, so longitude naman is either pa-east or pa-west. So yung ating longitude is 180 east and then 180 west. So all in all, yung isang revolution is equal to 360 degrees. Okay, so from yung reference naman to measure the longitude is the prime meridian or ito yung Greenwich meridian. So yung longitude at this point is 0 degrees. So if we move to the east, then this is 10 degrees longitude. Then this is 20 degrees longitude hanggang doon sa ibang direction. So this is eastward, so positive. So however, for the other opposite line, so this is 0 longitude. So this is 10, which is negative. So this is known for the 10 degrees longitude west. So this one is 20 degrees west longitude. This is 30 degrees west longitude. So it differs on the direction. So from the westward, so magiging negative yung longitude. For the eastward, magiging positive yung ating longitude. Okay? So for example, yung mismong, asan ba yung Pilipinas? So I think hindi na wala dito. So for example, andito yung points. So if your location is in this position, which means yung latitude mo is 20. Why? Because andito ka sa 20 degrees latitude. And then yung longitude mo ay 20 because from here 0, 10, 20. So, parang yung Cartesian coordinate system. So, this is 20, 20. 20 longitude and 20 latitude. So, okay. So, this is just the basic. Now, let's go to the definition of the spherical triangle. So before we start with the definition or before we introduce the definition, let's know first what is the difference between your great circle and a small circle. So when we say a great circle, imagine yung isang may plane. So for example, yung plane or yung isang page ng paper. If we use that plane or horizontal to cut this sphere into half, passing through the center, so that portion is called the great circle. So for example, in this illustration, so if we cut that the shape of the earth into half, in which yung ating cutting portion passes through the center of the earth, diba? Pag nagka-cut tayo pang center, we cut through the center of the earth. So this portion here along the cutted portion, or itong circle na to, is called the great circle. And another also we have here, if we cut the sphere into half, passing through the center, northern and the southern, then we can create the equator. So one of the examples of a great circle is the equator. Another example of the equator, another example of a great circle is the prime meridian. Diba yung prime meridian, we cut the earth into a eastern hemisphere and western hemisphere. So maraming example ng great circle. So when we say great circle, as long as an arc passes through the center of the earth. For the small circles, as long as yung portion is hindi siya dadaan sa center ng sphere, so that is called a small circle. Okay? So just take note the difference. So by the definition of a spherical triangle, okay, we have here Okay, so by definition, spherical triangle is the triangle enclosed by arcs of a three-grade circle of a sphere. So as you can see on the illustration, if this is the sphere, and we have one great circle here. This is number one, and another great circle, and then another great circle. So tatlong great circle. So this one is another great circle. And that three circles intersect, forming a triangle. So, nagpo-form siya ng isang triangle. So, that is now our spherical triangle. So, by illustration, we have another illustration here. Okay, so this is same with the, so for example, this is a great circle. For example, isa itong great circle. So, pa-circle siya, passing through the center of the Earth and the North Pole and the South Pole. And we have also another one from the North Pole, then pababa siya. So, this is another great circle hanggang doon sa opposite. And then we have 90 degrees. So, this is the equator, papunta doon. So, in that case, we can create a spherical triangle. So by definition, it is a triangle enclosed by arc. Since na-sphere na siya, hindi to straight line, but naka-arc. So para siyang curve. So it's not anymore a plane. So a great circles of a sphere. So take note na kailangan yung parts ng spherical triangle is enclosed by a great circle. So let's say we have spherical triangle ABC, where yung A is the interior angle as the center. At this corner, we have angle C is the included angle in this portion here. We have angle B in the included portion of the included angle here. So we have side A. So small letter A is the side opposite to angle A. And we have small letter B is the side opposite to angle B. We have small letter C is the side opposite to angle C. So for in this illustration, yung ating A is the, we can measure this as the latitude, right? So if this is the equator, let's just say, ito yung ating equator. Then from here to here, so yung A is a latitude. Then from this portion naman is another latitude. So this is also a latitude. So let's say that this A and B is in a form of degree measure. And then pwede din siya maging distance measure. So it depends on the situation and what being asked or what is given. So pwede siyang maging angle and pwede din siyang maging metric or in distance measurement. Okay. So the difference between the plane and the spherical. So yung ating plane, we all know that the sum of the angle, interior angle, we have B, A, and C is equivalent to 180 degrees. For the spherical, so the sum of the interior angles of the spherical triangle is greater than 180 and less than 540 degrees. So yung ating kabuuang angle in the spherical triangle is 180 to 540 degrees. So not less than 180, but not greater than 540 degrees. Okay, so we can write this one as let me check if okay, so the sum of all the angle is equivalent to 180 to 540 degrees. So not less than and not greater than 540 degrees. So yung sum ng A, we have A plus B plus C should not be less than 180, but not greater than 540 degrees. Okay. So we can compute the area of this spherical triangle here by applying the same formulas on the plane trigonometry as long as we have the angle. So let's say we have 1/2 AB sine theta. So let's just say this is our angle theta. So this is theta. We can compute the area of this triangle by this formula. So we have also another formula to compute the area of the triangle. We have here b squared sine A sine C 2 sine B. Similar for the plane trigonometry, we have B as the side. So let's say this is in the side. But take note, if we use this formula, we have AB and B squared. If the given is in latitude, you must convert it into a metric or in feet. So some cases, the given latitude is equivalent to 10 degrees. So if this is 10 degrees, you cannot use 10 degrees in this formula. You must convert 10 degrees into either in meters or into a feet or into a metric system. So I am going to give you the conversion unit for that later. So the same is true with this one, with the area b squared sine A sine C 2 sine B. So this is the included angle, and another included angle. But B here should be in meter or in feet or in nautical mile. Okay? So another formula to compute the area is we have pi r squared E over 180 degrees, where yung ating r is the radius of the sphere. So in this illustration, kung ano yung magiging radius mismo ng sphere. So if this is the radius, so this is also equivalent to that value, which is equivalent to r. And then we have this one, so equivalent to r. So we can use this formula if the given is the value of the radius of the sphere, then we can compute the area. But we need to find the value of E. Then what is E? So E is called the spherical excess. So yung spherical excess is just the sum of all the angle. Let's say your included angle A, B, and C minus 180 degrees. So that is your spherical excess. So you just compute this spherical excess and then multiply it with r squared pi over 180 degrees. Then you can cancel out the degrees since we have 180s here, and then the spherical excess is in terms of degrees, right? Since naka-angle siya, then we can cancel out the degrees, so the remaining is in terms of a distance. So it could be meters, in feet, or in nautical mile. Okay? So another formula to compute the spherical excess, if hindi given yung value ng included angle A, B, and C, then you cannot compute the value of the spherical excess. But if the given is the radius, we can compute the spherical excess by this formula. We have the area ng triangle over r squared. This is the area. And sine 0 degrees, 0 minutes, and 1 second. So this 0 degrees, 0 minutes, 1 second is a constant value to be multiplied. So another formula to compute the spherical excess is this one. So we have medyo complicated. We have here area mismo ng spherical triangle over r squared sine 0 degrees, 0 minutes on 1 second. So it's similar to this one. But you need to multiply it with 1 plus a squared plus b squared plus c squared over 24 r squared. But this formula can only be used if pag nag more than 160,000 na yung ating distance. For example, if A is equal to 170,000 meters, then we can no longer use the formula of this one. So since medyo hataas na ang kanyang value, so you should take note this formula if one of the sides of the spherical triangle is greater than 160,000 meters. Okay? So the same, yung R is yung ating radius mismo ng sphere. So this is the important conversion that we're going to use for this spherical triangle. So we take note that 1 minute of an arc. What do you mean by 1 minute of an arc? So kung napapansin nyo, for the latitude and the longitude, we have 10, 20, 30, 40, diba? 50, 60. Yung isang 1 minute, for example, yung pinakamaliit na 1 minute dito, 1 minute, let's say this portion here. So this is, let's say this is 1 minute. So if this is 0, 1, 2, 3, 4, then 10 degrees dito. The smallest portion here, which is 1 minute, that is equivalent to 6,080 feet or equivalent to 1.15 statute mile. Depende kung ano yung given, or equivalent to 1 nautical mile. In most cases, naka-nautical mile because the application of this subject is more on the navigation. So, more or less in feet or in nautical mile. So, some problem also uses in terms of meter. So, just compute what is the value of this 60, 80 feet into meters. I guess 1 nautical mile is equivalent to 1.8 meters. So just check the value. Okay, so 1 knot also. So this is the speed. So since this is application of the subject is for the nautical navigation and surveying. So 1 knot, that is 1.688 feet per second. So that is the, for example, for the speed traveling vessels in the navigation. So that is equivalent to 1 nautical mile per hour. So just take note the conversion of units and the equivalent of units as written on this presentation. Okay. So again, 1 minute of an arc is equivalent to 6,080 feet or equivalent to 1 nautical mile. So, sa plane triangle, meron din tayong spherical na right triangle. And sa spherical triangle, meron din tayong tinatawag na right spherical triangle. So, the same with, yung isang angle is equivalent to 90 degrees. So, in this example, yung ating value ng isang angle is 90 degrees. So, how are we going to, sa plane triangle, if we are given with the right triangle, we can use either the, Pythagorean theorem, or we can apply directly sine law to compute the remaining parts or remaining element of the triangle. But this time, for the spherical triangle, so we follow the rules set by Napier, so a scientist and mathematician. So this rule is only applicable for a right spherical triangle. Since hindi na natin magagamit yung distance formula, and we cannot use the Pythagorean theorem in spherical triangle, since hindi plane yung ating triangle and hindi straight line yung ating mga sides ng triangle, kundi naka-arc. Okay, so we have the Napier's rule. We have 2 rules to follow in order to compute the unknown portion of the spherical triangle. So number 1, rule 1. So the sine of the middle part is equal to the product of the cosine of the opposite parts. Then rule number 2, so the sine of the middle part is equal to the product of the tangent of the adjacent parts. So medyo magulo. So in the spherical triangle, we have one right angle which is 90 degrees. So isang ang 90 degrees yung ating included angle. So opposite to that 90 degrees, we take note that these are called the complementary angles. So when we say complementary, we just subtract it with 90 degrees. So if this is C is our 90 degrees, then opposite to C, since opposite to C, that will be now our complementary. So where yung ating A, if we want to determine the value of A, we need to subtract it by 90 degrees. If we want to compute the value of C, then we need to subtract it by 90 degrees. And if we want to determine the value of B, then we need to subtract it by the value of 90 degrees. So that is the definition of the complementary angle. So the two angles, we take the sum that is equivalent to 90 degrees. So let's start with rule number 1, then discuss it with another, and then rule number 2. I already discussed with this in the separate video last time that I gave you yesterday, but I need to focus more on each rule para hindi rin magkukurik. Okay? So let's start with rule number 1. So by rule number 1, it says here that the sine of the middle part is equal to the product of the cosine of the opposite parts. So in the rule of the Napiers, meron siyang tinatawag na pie. So yung pie charts. Yung triangle kanina, so let's say we have here, we have the right triangle. So if this is C, this is small letter C. We have, if this is A, and this is B. So this is small letter A and small letter B. So yung rule ni Napier's, parang mas madali daw ma-solve yung unknown parts ng spherical triangle if ipa-plot natin siya into a pie. So if we transform this spherical triangle into pi, so this is na, ito yung magiging features niya. Yung C, this is the 90 degrees. So if this is the C, yung opposite ng C sa spherical triangle is yung itong C bar. So yung C bar, ito yung may 90 degrees minus C. So kung ano yung opposite ni C, that is small letter C. So ito yung magiging opposite niya. So if this is C here, yung opposite niya, direct opposite niya is yung C. Again, another, si A. So yung katabi ni C bar, dito sa spherical triangle, yung katabi ni C bar ay si A and B. So similar din kung ipa-plot natin siya into pi, yung katabi ni C bar ay si A bar and si B bar. Okay? And then si C, balik tayo kay C, yung katabi niya ay si A and B. So similar din dito, yung katabi niya ay si B and A. So parang transfer lang natin niya into a pie chart. Okay? Okay, so let's go back to the rule. So the sine of the middle part is equal to the product of the cosine of the opposite parts. So since yung ating spherical triangle, we all know that C is always equal to 90 degrees. Okay, or either yung isang included angle is equals to 90 degrees. So let's say yung spherical triangle, given na yung value ni B and A, and therefore, given na rin yung right triangle na C. So, what if kailangan nating hanapin yung value ni A, value ni C, and value ni B? So by rule number 1, the sine of the middle part is equal to the product of the cosine of the opposite part. So let's say for example, kailangan nating isolve yung A. So from the rule, sine of the middle part, so let's say yung middle part natin is si A, is equal to the product of the cosine of the opposite parts. Ano yung opposite ni A? Yung opposite ni A ay si B and A. Diba? Ito yung opposite niya. Because ito, C and B is adjacent. Therefore, yung opposite ni A is B bar and A bar. So, if we use this into formula, magiging sine A bar is equivalent to cosine of B bar cosine of A. So if we read again the rule, the sine of the middle part natin ay si A, is equal to the product of the cosine of the opposite parts. So cosine of B times cosine of A. So that is now. So okay, another situation. Okay, so what if we need to determine what if wala tayong value ng A. So we don't have the value of A. So if we follow rule 1, middle part, let's say sine of A is equal to, ano yung opposite ni A? Opposite ni A ay si capital letter A and small letter A. So sine A is equals to cosine of A bar times cosine of C bar. Okay? Kuha? Another. Paano pag si B yung ating kailangan, or si B ay nandun sa kailangan natin kunin. So, we have sine of B is equivalent to, what is opposite to B? Opposite ni B ay si C and then itong B. So, sine B is equals to sine of C bar sine of B bar. So, that is what it means for the rule number 1. Okay? I hope you can follow the rule. Next is for the rule number 2. So, for the rule number 2, similar lang but nakatangent and then adjacent. So, take note that the sine of the middle part is equal to the product of the tangent, hindi na cosine, of the adjacent part. So, hindi na opposite, but adjacent. So, let's say, for example, is yung target natin ay si B. So, let's say, sine of B is equal to the product of the tangent of the adjacent part. Kung si B, opposite niya ay si C bar and B bar. So when we say adjacent, yung word ni adjacent, that is means yung katabi. So sine B equals to tangent of this one. Tangent of the A bar times tangent of A. Okay? So, same is true kung, for example, yung B prime, B bar. That is sine B bar is equal to, ano yung katabi ni B? Si C bar and si A. That is equal to tangent of C bar, tangent of A. Right? Paano pag si A, small letter A? We have sine of A equals to yung katabi ni A ay si B and big letter B. So, tangent of B bar times tangent of B. Okay, kung balik tayo sa rule, the sine of the middle part is equal to the product of the tangent of the adjacent part. So sa rule number 1, yung adjacent ng middle part equals to the product of the cosine of the opposite part. So yung mnemonics nito ay sin kuo and then sin taan. So sine, this is rule number 1 and this is rule number 2. The sine of the product of the cosine of the opposite and then the sine of the product of the tangent of the adjacent side. The sin co-op and the sin taan. Okay, let's have this example. So I already gave this example in the last, in the other videos. So let's try again. So solve the unknown parts of the right triangle in which A is 62, 40, 30. So given yung ating value ng A. And then B, which is 160, 34, 20. So given din yung B. And then we have C is equals to 90 degrees. Okay, so either we can use rule 1 or rule number 2 as long as complete yung ating given na values. So if we use rule number 1, so since we have C, A, and B, therefore kailangan nating hanapin yung A, kailangan nating hanapin yung small letter C, and kailangan nating hanapin yung included angle na B. So it depends on you on where you are going to start. So for C, so let's start muna kay C. So for C, we can use rule number 1 for C. We have here. So for rule number 1, yung opposite ni C ay si A and B. So no problem since given na yung value ng D and given na yung value ng A. Then we can directly solve the value of C. So we have, take note na may dash pa to, ay may bar sa taas since we have here dash sa itaas. Okay, since this is opposite to the 90 degrees. So sine C bar is equals to cosine B cosine A. So just substitute the values of A and then substitute the value of B. Then we can compute that cosine 160, 34, 60. Cosine 62, 40, 30, that is equivalent to negative 25 degrees, 39 minutes, and 6.36. So is that our final answer? This 25? The answer is no. Since we are looking for C, hindi yung C bar. Yung nakuha natin na value is only C bar. So to compute the value of C, we need to take the difference of C bar by 90 degrees. So to compute this C, 90 minus the value of the C bar. So that is equivalent to 115 degrees, 39 minutes, and 6.36 seconds. Okay. So now let's solve for, now we already have C. We have A, and we have side C, side B, and side A. So let's try to solve for included angle A, or in the illustration, we have A bar. So we can use the rule number 2, since if we are using this, since we already have C and we already have B, and yung target natin is to compute for A, meron tayong adjacent ng A, which is C and B, then we can use rule number 2. So as said, that rule number 2, the sine of the middle part is equal to the product of the tangent of the adjacents, in which yung tangent niya is si C and si B. And now, our formula becomes sine A bar, so may bar dito, tangent C times tangent B. So Sine of the middle part is equal to the tangent of the adjacent part, tangent C, and the tangent B. So just substitute the value of C and B. So in this time, since this is C bar, so this is A bar, and then this is C bar. So for the value of C, do not use this C since yung illustration natin is naka-C bar. So you use C bar. So you use the negative 25 degrees, 39 minutes, and 6.36 in substituting the value of C bar. Do not use the C. So if you take the substitute the value, we have sine A. We have tangent negative 25 degrees, 39, 6.36 times tangent of 160, 34.20. Then sine, arc sine, then A, we can compute A is equal to, that is A bar. That is A bar. This is A bar. This is A bar. So yung ating A bar is 9 degrees, 45 minutes, 5.92 seconds. But our target is A, not A bar. So we need to subtract this by 90 degrees. So our value of the A, so the value of the included angle A here is equivalent to 90 minus 9 degree, 45 minutes, 5.92 seconds. So this will be now the value of A. So your turn, you solve the value of B. So we have already A, C, and B. Then at home, you solve the value of B. You can use either rule number 1 or rule number 2. So for rule number 1, so we can use sine B is equal to cosine A, cosine B, or you can use the tangent. You can use sine B equals to tangent C and tangent A. So it depends on you. Okay, so just remember the sin coop and the sin taad mnemonics. So this is applicable only for the right spherical triangle. Now question, what if the spherical triangle is an oblique? So which means wala siyang 90 degrees na included angle. So similar sa ating plane triangle, meron tayong law of sine for the spherical triangle, and meron din tayong law of cosine for the spherical triangle. But different formula for the cosine. And for the sine, just change the numerator since the sine. So let's have here the law of sine and the law of cosine for the spherical triangle. Okay, so for the oblique triangle, so let's say walang 90 degrees yung ating angle. So for the law of sine, meron tayong tinatawag sine A over sine A, which is A is the opposite to the included angle A. Sine B, B is the opposite angle to B. Sine C is the opposite angle to C. So take note, we have sine A here because yung ating A is in terms of angle. So let's say, so this is in longitude. So in terms of angle, kaya tayong may sine dito. So B is in terms of latitude. So this is a sine. And C also, we have here is a latitude. So magiging sine. Where yung ating capital letter A, this is the included angle in the spherical triangle A. So B is the included angle here. And C is the included angle here. So just similar to the law of sine for the plane trigonometry, but we have here the sine since it is in terms of the angle. Okay. Okay, for the law of cosine, we have formula cosine is equals to cosine B, cosine C, sine B, sine C, cosine of your A. So which yung A is the angle opposite to the angle here, cosine A. So similarly, if we're going to find cosine B, just use cosine C, cosine A plus sine C, sine A, cosine of B. So whatever is here, then that is the opposite to that angle. So similarly for cosine C, if we were looking for C, as long as you have the value of A and B, then plus sine A, sine B, cosine of the angle B. And we have also law of cosine, separate laws for cosine formulas for the angle. So what if given yung angle and we are looking for the angle? So for the law of cosine for the angle, okay, for the angle, we have cosine B, negative cosine C, cosine A, plus sine C, sine A, cosine of B. So similar to other angle, if you want to solve for A, angle A, that will become cosine A is equal to negative cosine B, cosine A, plus cosine B, cosine A, cosine of small letter A. So just look. So this is the derivation of our cosine law for the spherical triangle. So I have a separate discussion on this one. I already gave you the link for that on the mathematics of sphere. Check out for the derivation and the discussion for this presentation or for this slide only. I created a separate videos on this one. Okay. So this sample problem, I already discussed this one on the other video. So we have here solve for the unknown parts of the spherical triangle having we have a value of A here, which is 60 degrees. B is equals to 150 degrees. So this is 150 and this is 60. So the illustration is not too close to the given, I'm sorry. We have C, which is also equal to 60 degrees. So now we are asked to find the value of A, B, and C. So you can use either law of sine, law of cosine for the sides, and law of cosine for the angle. So for the distance angle C, so let's try this one using the law of cosine for sides. So take note of the formula. So cosine C is cosine B cosine A. So we already have the value of A, B, and the C. So that this is just direct substitution. We can compute the value of C. So our cosine, so C is equal to 102 degrees, 30 minutes, 14.1 seconds. So just check if the solution is correct. So however, if we are going to look for A, we can either use na law of sine and the law of cosine. So let's try this one to solve the included angle A or B. So we can use the sine law. So substitute, we have here, if you're looking for sine A, we can use this relationship or whatever is available. Sine C, sine A over sine C, where you small side angle C, we have the side angle A and the included angle C. Then direct substitution, we can get now the value of A. So, and then for side B, if you're looking for C, this is equivalent to sine side angle C times sine of the B over sine C. Okay, then our value, direct substitution, then the value of A is 50 degrees, 11 minutes, and 40 seconds, and your B is 26 minutes, 26 degree, 19 minutes, and 46.21 seconds. So let's just check muna the, I think we have a problem with B. So that is, we have arc sine of B. If we are looking for B and then we use C, check the value of B if this is correct. So this is sine B over sine of B. We have sine, we use C over sine of C. So our sine of B is equals to sine of B, small letter B times sine of capital letter C over sine of small letter C. So sine B equals to sine, what is B? B is 150 degrees times sine C. C is 60 degrees over. We have sine small letter C is 102 degrees, 30 minutes, and 14.1 seconds. So that is 26:19. So that is correct. Okay. So just use the formula. If just identify what is given and what is asked and what is the most preferred formula to be used to compute the remaining sides of this spherical triangle. Okay. So that is the end of our lecture. So I will be giving you additional items to be solved on the quiz given, and then I will be posting the schedule for our long exam for the spherical triangle. Then we have our final examination. So again, thank you for watching this video. I hope you spare time to study this material, since this is very important for the proceeding subjects that you will be taken up in this course. So I hope you find it this reference helpful for you in the future. Okay, thank you again and good afternoon.